Hello, we are going to do this sequence here. The natural log of n plus 2 over the natural log of 1 plus 4n. Does it converge? Does it diverge? We're going to answer that in this video here. Let's get right into it. So, is this sequence converging to one point or is it diverging into infinity? You're doing some weird crap at the end. We don't know. But let's evaluate it as, let's say, okay, the limit as n approaches infinity, what is really happening at our function? Well, let's take the limit, and I'm just going to draw a bracket or a parenthesis because I can't draw the squiggly thing again. I suck at it, okay? Bear with me, guys. What is the limit as n plus 2 over ln of 1 plus 4n? I'm done. I just have to plug in infinity. Okay, the natural log of infinity over the natural log of infinity. 0. No, it's infinity over infinity. That's indeterminate. This does not tell you if the limit exists or not. It's just indeterminate, okay? So knowing that this doesn't exist, we need to do a rule, which is L'Hopital's rule. L'Hopital's rule basically says, if I have a function f of x over another function g of x, f of x over g of x. If I want to find the limit as x, which is our input, is approaching some value a. And let's say for this you get 0 over 0 or infinity over infinity. So what did I say? Limit as our input approaches some value, and if that approaches 0 over 0 or infinity over infinity and it's indeterminate, what we can do is say, no, this is actually going to be equal to f prime of x, the derivative of the top, over the derivative of the bottom. And when we evaluate x, we should get the value a, and not 0 over 0 or infinity over infinity. So let's go ahead and solve using L'Hopital's rule. So get rid of this crap. I don't want to evaluate the natural log of something at infinity. No, I'm going to take the derivative. So let's find the derivative respectfully for each. d dx of the natural log of n plus 2. So what is that? What is the derivative of this here? We're going to go piece by piece. Well, remember, for any natural log function of x, and I want to take the derivative d dx, well, that's going to be simply equal to, I'm going to take the derivative of the top, so I'm going to say x prime over x. Okay, so in this case, if it was natural log of x, it would be 1 over x. Okay, kind of just a refresher. Hopefully you remember that from Calculus 1, but if you don't, it's okay. So we're saying the natural log of n plus 1. Well, what's the derivative of that? Well, it's just going to be 1 over n plus 2. We're going to do the same thing for our next function. I'm going to go a little fast on this because hopefully you're catching on. 1 plus 4n. Well, that's simply just going to be 4. Derivative of 1 plus 4n is 4. And then this is going to be over 4n plus 1. So we can go ahead and say that, okay, this limit is really equal to 1 over n plus 2 over our bottom term, which is 4 over 4n plus 1. Okay, pretty simple here. I'm going to do a little bit of cleanup on this because, quite frankly, this is ugly. Very, very ugly. So let's go ahead, clean it up. So we're going to move n plus 2 to the denominator. We're dividing by 4, so we're going to keep that. And then we need to bring this up because it's a denominator of a denominator, which is basically the numerator. So I'm actually just going to omit the 1 and say this is 4n plus 1. And then I'm going to distribute this 4. So this is going to be 4n plus 8. Alrighty, so let's plug in infinity. What do we get? Well, you're going to notice, again, we get infinity over infinity, right? 8 times infinity is infinity. I don't care what other multiplying we're doing of infinity. If it's infinity, well, it's infinity, and there's nothing greater than infinity. So it is infinity over infinity, right? Because 4 times infinity, infinity. 4 over 4 times infinity, infinity. So it's still indeterminate. we need to use L'Hopital's rule once again. Hopefully this derivative is a lot easier for you. This is just 4 over 4, okay? Which tells us, well, let's evaluate the limit as we approach infinity. Well, there's no values to plug in, so this is simply just 1. So hopefully, I went a little quick. Let me explain what I did. We took the limit as n approaches infinity. We found that it was indeterminate. Basically, we can't determine if the limit really exists or not because it's indeterminate. It's in an indeterminate form, which is infinity over infinity. We used L'Hopital's rule that says, okay, well, that's equivalent, but just take the derivative of the top and the bottom and evaluate it then. That should give us the limit. We did that. Well, we didn't really get a value that was determinate. It was still indeterminate. If we have an indeterminate form from a previous function, we are allowed to take L'Hopital's rule once again. And we did that, and we found that it is 4 over 4. Let's evaluate it at infinity. There's nothing to plug in. It's 1. So given that this is 1, we know that it is going to be convergent to 1. So this is a convergent sequence at infinity to 1. Hope you guys enjoyed. If you did, please drop a like, comment, and subscribe. I hope that you have a wonderful day.